have a look on the what exactly our requirements and all these kind of the conventions. And in this session, friends, as I said, we'll see the what exactly the Spark and how we are managing the ecosystem of this Spark and why this particular Spark is booming today and which are all the offerings and Spark distributed execution. Okay, these kind of the conventions are very much helpful in the understanding of the Spark orientation, friends. Okay. Now, coming to the Spark representation and all the things, first we need to define what is exactly the Spark. Because if I'm asking you what is Python or what is Java, definitely you can give me the answer like they are programming languages, which are giving all the sort of the conventions related to the development. Now, similarly, if someone asks you, okay, can you give me the essence of the Spark? Can you explain me what exactly the Spark is? So here, guys, the name is Databricks. Okay, but we are talking about the Apache. So very simple, though Databricks released this particular Spark initially, there is a small story, guys, here. Databricks, because if you are observing the time big data orientation, okay. So friends, here big data is only two important aspects we're considering. One is the Hadoop based ecosystem, and second is the Spark oriented ecosystem. And if I'm talking about the kind of the big data orientation with respect to Hadoop, this is a disk based. Okay, disk based in the sense, suppose if it is performing any sort of the activity, performing some Hadoop distributed file system storage or performing some sort of the MapReduce kind of the programming. All these things are related to the disk based. That means it depends on the disk so as to access the data. And if any temporary information is generated, and that information is also should be stored in the disk based. So obviously, guys, if I am talking about the disk based, there is a IO glitch actually. Every time you go back to the disk and get the appropriate information, so it is taking lot of time. Okay, this IO is taking a lot of time. And if you are considering the Spark kind of thing, is the in-memory computing, friends. Okay, in-memory computing specifies that just it is not using any disk kind of the aspects. So in a way, whatever the functionalities, whatever the aspects I'm having, so just they are managed by the in-memory kind of thing with the help of the APIs like RDD, data frame, okay, all these kind of the constructs. So one of the initial key factor, one of the basic key factor why Spark is having that much potentiality is due to its in-memory computing. Okay, in the architecture, I will be explaining all these things in elaborately, friends. But initially, how Spark is gaining the potentiality compared with the Hadoop. And coming to this Hadoop orientation, guys, there is a replication. Okay, if I'm considering this as a first point and this is the second point, can someone help me, guys? What do you mean by replication in terms of okay, if I'm asking you, maybe it's not like database orientation. Okay, how do you refer the replication and what is the advantage or how you can see that replication? So this day and today and tomorrow, I'll just ask the questions in the chat. From Monday onwards, I'll pick a person. That is a general practice thing. Just I'll pick a person and I'll ask the questions. That is a so that you all get the kind of the conventions. Okay, what exactly the thing and all. Oh, Krishna, you are there in the call. Welcome, my dear friend. Nice, nice to see you. And Vedant is there, my old friend. Harish, Harish is there. Okay, nice, nice. Akhil is also there, right? Nice. Welcome, you guys. Okay. So the replication, friends, actually the Replication is nothing but storing of the same file. Suppose I'm having file one, and I'm going to store this file one in multiple locations. So due to some issue, as I'm dealing with the heavy data or big data kind of thing, definitely there is a sort of dependency on the data. It's not like KBs or MBs, maybe gigabytes or petabytes or picobytes. Like that, it goes on. Okay, heavy data. No? So if we are not able to store that particular data perfectly, our entire things are getting collapsed. So what we need to do is we need to place them in the replication orientation. Okay, but guys, in terms of this kind of Spark, there is no replication kind of the aspects. If you are managing the without replication, there is a topic called RDD, resilient distributed data set, how it is managing the conventions and all these kind of the aspects, So just it is by default, as I said earlier, by nature or by design, Spark is fault tolerant. Okay, so this particular property keeps that particular Spark in a better way, guys. Okay, this is how you can see the orientation of the replication in terms of the Hadoop and as well as the Spark. And most important thing, your MapReduce programming. The people who are having the background of MapReduce, it is a heavy coding, friends, definitely. Heavy code, and moreover expertise in Java, especially this is the default language of the MapReduce, or Python is mandatory because a lot of code we need to write and all these kind of the conventions we have to perform. So, but whereas in terms of your Spark, this is a lines of code is very simple, simple coding, okay, and it is supporting almost all famous programming languages, Python, R, Java, okay, Scala, like that we're having various kinds of the aspects, guys, just I'm making use of all the conventions. Either the programmers who are having the background of Java, they can venture their Spark applications. Even the members who are having the R, which is a statistical programming language, especially in terms of machine learning, we are using this R. Or the people who are having the background of Python, they can straight away make use of the convention. One more point I want to highlight here, guys. See, at the time of designing this Spark, two important components are taking place. One is the Mesos, and other is the Scala programming language. Friends, observe here, Scala is perfect object-oriented programming and functional programming. Okay, object-oriented and perfect functional programming. But only the thing is, the entire Spark is written in Scala. Entire Spark is written in Scala. So for Spark, the default programming language is Scala, of course. Okay, the default programming language. And Mesos, guys, this is a cluster management where if I am submitting my Spark job, it is allocating the resources and performing the activities. But the problem is at that time, maybe around 2012 to 2015, okay, the transformation happened actually. So at that time, we are having Hive and as well as HDFS, MapReduce, all these kind of the conventions. But the problem with that is, as I said, the people should familiar with Java, and because this is the native programming language, and moreover, is a disk-based aspect. And one of the barrier is, friends, this thing batch processing actually. The entire Hadoop ecosystem is only dealing with the batch processing. But the people at that time, they're looking for the interactive, iterative, and as well as the streaming. So these three are perfectly available in the Spark architecture. Okay, iterative, interactive, and as well as the streaming kind of the things. Because this batch processing, though it is parallel and distributed, But all the kind of the applications may not be suitable to the batch orientation. Okay, so just what we are seeing here is rather than making use of this batch and as well as the heavy code and disk-based kind of thing, people attracted to Spark Friends actually because due to its flexible support of the interactive behavior, iterative nature of the programming, and as well as the streaming kind of aspects. Okay, so if time permit, definitely I'll take one case study and I'll give you the aspects of the streaming also, friend, because Spark itself support the streaming. Okay, Spark streaming along with Spark. Okay, just we are adding one more tool called Kafka. Okay, these things are also helps us to perform the streaming aspects. Okay, so now the question here is two important barriers, as I said. One is Spark Mesos usage, and another is Scala. Because Scala, people very rarely use. Like if they want really the pure object orientation and functional programming, then only people get uh, use these kind of the Scala. But heavy programmers, that time, Python and all these kind of the programmers, so they insisted the Spark designers to release the version of the Python. So now we are having the PySpark. This is one thing. A small history I need to tell. If I'm considering the map reduce friends, okay, so simple thing is a parallel programming model. Okay, which is a parallel programming model of Hadoop ecosystem. Okay, na? Of Hadoop ecosystem. And this particular parallel programming model, okay, so requires some sort of, so suppose if I'm running the job, I should submit this job to some sort of the cluster because the cluster is providing the resource friends actually. It is providing the resource. And for this particular job, I need some sort of the space and as well as the CPU timing. And these two things are nothing but the resources. So your cluster provides these two aspects so as to execute your job. Now, friends, actually all Hadoop MapReduce developers, they are very much familiar with the AND. AND is very simple, guys, like at another resource negotiator. Okay, what this particular ad does is ad picks up the corresponding jobs and it is going to allocate some sort of the resources and those resources can be used by this particular job to execute and perform the activities. Now the requirement is Spark, okay, need to release the Python oriented version of the Spark. Second thing is at that time, the people are very much familiar with ARM rather than the Mesos because Mesos is a default cluster management tool where Spark is running on top of that Mesos. But ARM was established by that time and people are very much familiar with ARM usage. Now the thing is, guys, so on top of this ARM, the people started using PySpark and they got good results compared with Hadoop. So now the Spark is becoming a standard. Okay, this becomes a standard compared with the Hadoop orientation. Okay, now of course, periodically what I will do is as a kind of the case study or the generic discussion. Definitely, I will give you how Hadoop complements Spark and how Spark complements Hadoop. Those things definitely will see guys. So now we are in the juncture of Spark released the Python based kind of the version, which is the PySpark kind of the aspects. Another important thing is though Spark is tailor made for the Mesos, but the Hadoop developers or MapReduce programmers tried to use this ad and they succeeded, friends, actually. So it's the biggest hit. So the combination of the ad and as well as the Spark and the two Spark conversion into the Python which is nothing but PySpark orientation, is giving excellent results. So now, if I am coming back to this kind of the explanation, whatever I have taken, so which is 100% open source. Now, you see, guys, whatever the Hadoop ecosystem tools, whatever the Spark orientation, in fact, they are the open sources. If you go to the Apache website, just they will be providing all these kind of the conventions. Let me jump into that. 1 minute, guys. So this Apache, uh, just if I'm opening this convention, let me share this screen, friends, so that you also have a look on that. Apache, right? Okay. So it's a is our favorite thing, guys, actually. So because this particular Apache provides us all the open sources, no matter whether that is Hadoop or Spark or whichever the convention, you know. So it is latest kind of the projects, whatever the projects we're using in terms of Apache base, all these things. And I already have shared you some kind of the community things, friends, before starting up the session. So just to follow those kind of the communities, maybe in terms of GitHub or all these kind of the aspects. So they periodically conduct some sort of workshops and as well as all these things. If you attend those kind of things, you can easily get what's going on and how we are making use of the conventions, whether we are going in the right direction, all these kind of things. Now, just if I'm clicking on this Spark, just it is giving all the documentation. I strongly recommend you guys just go and have a look on this documentation. Though I am covering these kind of the aspects, but still you need to verify. Okay, so verify the kind of the things. Excellent, Surendra. Surendra says replication, the same type of the data into different nodes. If there is data loss, the replication helps. Excellent. Okay, and Vedant, duplication of blocks to different nodes to avoid failure. This is more into the Hadoop distributed file system. Basically, friends, your replication is something like which really helps us, okay, to maintain the data. Though if any problem is there, if any failure is there, but still we can make use of the convention with respect to the replication. Now, this documentation almost in our training and all these things will be using this documentation only, friends, no problem. And ecosystem, I will be explaining this thing in a while. Just have a look on this. And moreover, adaptive query execution. So generally in the certification exams and all these kind of the things, we are getting some sort of the questions from adaptive query execution and some sort of especially in RDD or data frame APIs. Okay, and from the Spark architecture along 20% of the questions out of 60 will be getting some 16 to 17 questions. Okay, those kind of the conventions. Well, I'll float some sort of the questions also, friends, along with the course. Okay, whatever the topics we are discussing. In line with those topics, if any previous questions were there or expected questions were there, so that you can also have a look on that and go ahead with your training at the same time, some sort of the certification also. So here, if you consider these aspects, friends, SQL and data frames, Spark streaming, all these things, and one good news is we need not install anything, guys. We need not install anything. Just we are having some Databricks community edition. You know, if you see, and I can make use of this existing account. So just you can take the use of the account, and moreover, just if we are making use of this particular Databricks kind of the aspect, what you need to do is just you can type this particular thing, Databricks uh, cloud community. So just it will be taking you some sort of login screen. Maybe I already registered for this so that it is asking like that. But just you need to create one login, guys, with respect to your understanding. Just based on that particular community edition only we are going to work. If you observe this panel, guys, these are all the offerings. Of course, soon we are going to get the proprietary edition soon after getting the project and all these kind of the convention. But now, as of now, just we can make use of this Databricks Community Edition, which definitely gives us some feel of whatever the constructs. Okay, only the distinction is here we are trying to use very less resources. Like the cluster is very handy and very simple. But in the reality, the cluster is equipped with full storage and as well as all these things. Otherwise, all the operations and all similar. Okay, there is no, you need not worry about change of the code or something. Whatever the code we are applying or we are learning here, the same thing can be leveraged to your cluster, proprietary cluster also. Okay. Now, a notebook, the people who are having the background of Python, they are knowing about this Jupyter notebook. Just to create a notebook, friends. Here it asks, okay, however, day one, Spark aspects like that. And here, as I said, multiple programming language would be there, but our interest is on Python. Now, most importantly, friends, we need to create a cluster actually. So let us, without cluster, let us try to create the notebook. Okay, so just it is not having any cluster because cluster, if you consider, friends, cluster is a kind of the platform where your job submissions will be handled. With respect to that particular cluster only, we are maintaining the convention of submission of the jobs and execution of our code or whichever. So in some cases, will be provided with AWS or Azure or GCP kind of the cloud platform. And on top of that, you can make use of the convention. So there are certain considerations, friends. Maybe I can give here only. So just to give a glance of that particular thing in a clear cut way. The important aspect here, friends, like your installation process may be, sorry, so maybe like Spark, if I am taking, either I can go with the Databricks Community Edition. Okay, so this Community Edition is one thing where we are generally used. Okay, without installation, directly we can pick up the notebooks and we can use. Second thing is, friends, virtual machine. I'll show that thing also. Virtual machine installation, where there we can configure your Spark and as well as either PySpark orientation or Scala orientation you can perform. Okay, so it's a standalone kind of thing. Within our machine only, we are going to run the tasks. There is no cluster support and all. Third thing, either AWS or Google Cloud Platform or Azure. Okay, and this particular cluster, no matter whether now we are using Azure actually, maybe in our community edition or in our company also, for the sake of launching of Databricks projects, we prefer the Azure orientation. But logically, friends, there is no distinction whether that is the AWS or GCP. Hardly what they do is just they provide some platform according to our requirement. Is a pre-configured cluster actually. Okay, is a pre-configured cluster. So just with this, you can make use of whatever the things, but periodically, I'll show you the virtual machine also. If I'm introducing all these things at a moment, you may be getting some intrinsic kind of the explanation. So I'll slowly inject all those kind of the aspects. Now, going back to our community edition, first let me create the cluster in the meantime so that it takes some time, guys. First time the cluster creation is taking some time. And once the cluster has been created, then you can directly make use of that particular cluster for our programming and all. Now, if I want to run any task, okay, I'll explain this trend. What exactly Spark? What do you mean by Spark context or Spark session? I'll explain. But just there are two options. Either I can select this explicitly. Okay, run. Okay. select resource. What it is asking friends, attached cluster is terminated. This notebook is attached to a cluster which has terminated and you do not have permission to restart it. Would you like to attach to a different compute resource? Okay. So now what you need to do is without cluster, you cannot perform the activity. That is the first thing. No matter whether you're using the AWS, GCP or Azure, or else you are using the Databricks Community Edition. First thing is you need to assign our notebook to the cluster because that cluster provides the resources for us. So what I'm doing here is guys, just I'm again the same panel, okay, like you just to create. Here we can mention the cluster. Now, however, we are working on the day-to-day basis now. Just will give the date. Okay, so 9 to 23. Like that, in a way, we can feel that okay. So today we have done these many activities. Now let us try to understand what exactly this cluster provides to us. It is providing one driver. Driver is nothing but main program or Spark context or Spark session, and it is providing us some sort of the memory along with the uh, kind of the course and Databricks unit. Okay, 1 DBU it is providing. Now, however, we are selecting some name, and here plenty of runtime environments are there, friends. Okay, and most latest kind of aspects we are selecting. Okay, by default it only selects. And now just simple leave all the defaults. You need not worry about that. Just to create the cluster. Definitely it takes some time frame. First time maybe 2 to 3 minutes it is requiring. So just it is pulling the appropriate machines because pre-configured one, all that Spark need to be available. And if I'm using Scala or PySpark, all these kind of the conventions. Because if you know, if you see this example, actually here we are having various supporting languages actually. So that the cluster should be in such a way that it should support the Python based kind of the coding, SQL based kind of the coding, Scala and all. So the four categories of the programmers, and of course friends, Python and SQL, however, we are using in terms of Spark SQL, in terms of the PySpark we are using. Scala also, let me see if I could come up with some kind of the case study. Definitely, I will give you some essence of the Scala also, okay, without any problem. R is out of context, friends, because you know, if you are making use of this R programming, it is a bit deviated to the machine learning aspect. Okay, so it provides some sort of machine learning tools and as well as the kind of the packages. Otherwise Python, SQL, Scala, they are a typical programming environment where you can have the activity of data engineering and as well as the machine learning also. But in terms of our majority of that R packages are skewed to the ML kind of the algorithms. Okay. So this is what how you can support your cluster. Still, it is taking some time. What we'll do is we'll go back to our discussion, and I'll try to give you some sort of architectural aspects and all the architecture. Because friends, one thing coming to the big data kind of the environments. Understanding of the code is very simple, friends. There is no doubt about that. But only the thing is, we should be very familiar with our architectural things and how the data is flowing and how the job is executing internally. Because if you are not having that connect, everything becomes a chaos kind of thing. So please be with me. Please be attentive, guys, so that let us complete these 4 points because we started with what exactly Spark. Simple and easy use APIs. It is too early to say because now if I'm saying also, people may not agree with me. But after 5 or 6 sessions, definitely you realize how simple these particular APIs compared with any other programming language. In-memory processing. This already we have realized. Like Hadoop ecosystem follows the disk-based environment, whereas our Spark, especially in terms of RDD discussion, we'll see how this persistence and in-memory computing happens, all these kind of the things. And distributed computing platform. Now tell me, friends, just I am asking one scenario. What exactly the distributed computing? Okay, definitely from your experience of your engineering or PG, definitely you should have this study of this distributed environment. How do you refer this distributed computing, friends? In any simple terminology. Okay, like what do you understand? What do you mean by distributed computing? How do you refer the distributed aspects? Okay, so I'm moving ahead. Just I'm waiting for your response, guys. So in the meantime, just to pick up, even if you Google also no problem, friends. Some or other way you need to have the understanding of that particular question, whatever I have asked. Then you need to come up with your analysis. That is the process. Okay, I need not wait for 2 or 3 minutes now, which is unnecessarily killing the time. But I need to give you the task as we are talking about the parallel processing. So along with my session, you need to think also. Okay, right. And most important point is, guys, unified engine which supports SQL, streaming, ML, and graph processing. Especially in the Facebook kind of thing or heavy data is there. If you want to establish a kind of the uh, visualization, then you can go with the graph processing. Machine learning libraries such as classification, regression. However, as a primer course, we are giving to you guys the ML also. Streaming, like real-time data, log file processing, or any real-time streaming. If I want to get, then I can make use of that. And most importantly, to simplify the coding and to reduce the lines of the code, we are having the Spark SQL, which is very handy and which is very interesting, friends. Okay, right. Now, moving ahead, these are all the points where periodically we need to realize and we have to conclude ourselves. Okay, not a big deal, no? Automatically. Now, if I am referencing the understanding or observation of this Spark architecture, whatever the discussion we had, the entire discussion can put on a kind of the image, friends, actually. So let me paste that particular thing here so that we'll spend some time. What exactly the kind of the aspects that we are going to study in the Spark orientation. These are all the offerings of the Spark. Now this is the base layer. Now we are the cluster now as just now we started. Okay, this particular cluster might be Spark standalone, Air, Apache Mesos, Kubernetes, whichever. Okay, these many forms of the backgrounds or clusters are there. According to the requirement, the user, maybe some of the practitioners or researchers, they may be having their own cluster so as to perform some kind of the aspects. Whereas companies can provide ARM-based cluster or Kubernetes so as to perform the activities. And most importantly, friends, the low-level API, okay, RDD. Why we are using this RDD is the entire fault tolerant mechanism is with RDD only. Okay, we are having extensive discussion on that resilient distributed data set. At this moment, friends, you observe that RDD is a kind of low-level API which is providing us some sort of the storage along with the fault tolerant mechanism. Okay, just to observe that point. Now, what do you mean by Spark core? On top of this particular RDD, we are having various programming languages. Of course, Scala is a default language for the kind of Spark, and of course, the entire Spark was designed in Scala. Okay, so Scala becomes obviously the default programming language, but majority of the developers using Python. Okay, because of its flexibility or because if I'm adopting Python, I can do the generic programming, I can do the database programming, web-based programming, at the same time object orientation, and then this side data engineering aspect with NumPy and Pandas, and our machine learning kind of aspects with scikit-learn. Likewise, we're having plenty of opportunities to study related to the Python-based kind of things. And of course, friends, here this is a JVM-based, your Scala, and of course the Spark running on top of the JVM. Though I am using the Python or R programming, but still they should run on top of this JVM only. So, in terms of Hadoop ecosystem, in terms of the Spark also, without the support of the JVM, there is nothing to do, guys. Okay, internally Java playing a vital role. So there is no problem for the Java developers. Okay, though Python is gaining the potentiality, it is underlying kind of under the hoods. Java is playing a um, real adventures. Okay, really that. Now, the most important thing, friends, catalyst optimizer and as well as the tungsten execution. I strongly recommend you guys, just if you are referencing the Spark Catalyst Optimizer and Tungsten, just we are having some sort of, just let me show you that. Already I have picked up that information for us. Um, 1 minute. Okay. So before going to explain that, our cluster is ready, friends. I want to show you how our cluster is performing. Just you see this. Just I'm having this cluster details with us. So this shows that cluster is running. Now we are having this thing. Just now we have created our notebook. What you need to do is I'm trying to run some code actually. Okay, Spark, select resource. Now you see earlier it has not given any resource. Now just now we have created the cluster and I can attach this particular attach to an existing compute resource. Just the summary of the information. Okay, attached. Just it is attached. So now you can easily see, friends, our cluster has been attached to this notebook because to run that particular notebook, definitely I should have the support of the cluster because that cluster itself is providing the resources. If you are making the notes or if you are taking the notes, definitely you need to have the pen and paper. Now, similarly, if I want to submit my job or if I want to run my job, definitely I should have the kind of observation. Okay, kind of cluster I need to have. Now, this is the most important convention, friends. The point here is this is a pre-configured one. Whereas sometimes, we may be configuring some sort of the cluster for ourselves. Cluster is okay, but these things, virtual machine installation or some sort of the AWS usage of the cluster, because this Databricks itself is a tailor-made kind of thing for the Spark, because they are the one who designed the Spark and who are promoting the Spark with the support of the Apache by making Apache as a partner for the open source. Okay, but the point here is not all the other tools such as other clusters have direct notion of these Spark or these things. Now, one more component is there. Just if I'm giving this Spark context, see here, friend, the distinction. Just there is a default identifier, okay, where this particular Spark object is having some sort of representation. Like, if I'm giving that convention, it is having version, UDF, table, streams, stop, SQL, Spark context. Like that, I'm having many observations here. So this particular Spark object provides some sort of the access or entry point to many applications or many functionalities. Now, if I am giving this Spark, okay, just it is providing us some sort of the information, friends, if you observe this. So what we are doing is just taking this convention. Just if you are making use of this convention, let me paste this so that you can also have a look on that, which are all the components we were talking about. Just have a look on that, friends. Okay. And these components, okay, are the real information to understand related to the Spark. Now, if you observe, this gives the Spark session actually. Friends, Spark session and Spark context are two important aspects. Let me give you the clarity because many of the times the people getting confused about what exactly Spark context and what do you mean by the Spark session. I'll give you the clarity here. So our Spark context, okay, what exactly the Spark context refers to is just I'm having the initial release as Spark 1.x. At that time, they are having the Spark context. They are having the Spark context. And one more important thing, friends, if I want to use the Hive, then I should specify the Hive context. And if I want to make use of the SQL context, then explicitly I have to mention the SQL context. That means your Spark context only dealing with the Spark orientation. If I want to run Hive or SQL kind of thing, explicitly I need to mention these kind of the context apart from the Spark. It is in the 1.x edition. But you know, guys, from the Spark 2.x or 3.x, we are having the Spark session. We're having the Spark session. Now, have a look on this, guys. This Spark session internally have the access of Spark context, Hive context, and SQL context. So that means if I'm only using the Spark context, I need to use the construct supported by the Spark only. And explicitly, we should mention that Hive context and SQL context separately. We should make use of those two aspects separately. But if I'm using the Spark session, okay, Spark session automatically having the Spark context, Hive context, SQL context, so that with the Spark session, okay, friends, with the Spark session, I can interact with Spark context, Hive context, or SQL context. However, our current version is Spark 3.x only. We are no more using the 2.x. We are using 3.x kind of the version. So if I am specifying the Spark session, then it is embedding all your context. Okay, you need not explicitly mention the Spark context, Hive context. But in terms of the Spark 1.x, if you are using, and not only in 1.x, in 2 or 3 also, if you are explicitly using the Spark context, then you need to specify separately the Hive context and SQL context. Okay, so that is the distinction. Now, if I am going back and explaining that thing, definitely you will be connecting the dots. Let me show you that thing, friends. In terms of this addition, so at the moment I am giving the Spark, and if I am running the cluster, it is giving the Spark session, okay, which internally having the Hive and as well as the Spark context, and this version 3.3.0. And as usual, without specifying anything, by default, master is local, and your application name is Databricks shell. Okay, as I have not given any sort of the application. Now, whereas this SC is the Spark context, friend. This is nothing but your Spark session orientation. Whereas this SC specifies that Spark context. Okay, Spark context. This Spark context, no difference. Only the thing is, it is not scoping the Spark session Hive and all these things. It is only talking about the context. Another important thing, guys, though we are using the community edition, Databricks provides us some sort of the UI. Okay, Spark UI is one of the tool where all the developers and programmers dependent on, where so as to check whether our job is perfectly running or what exactly the kind of the aspects we are doing. If you click on this, it is providing us some sort of information like environment, SQL, and most importantly, in a while we should see the DAG kind of the functionality. So that DAG provides directed acyclic graph kind of thing, where your jobs are converted into the stages, and those stages are converted into the tasks. Now you see here, if I am observing the jobs, just this information I am getting, and if you consider the stages information, which is a combination. So now which is scheduling first in first out kind of the aspect, and our storage, what exactly the storage provided to us, and then the environment. Okay, so all these kind of the environmental variables you can see where you can study about, because as we are not administrators, we need not worry about these things, friends. Okay. Now, executors, I'll slowly introduce all these terms, friends. What is a job? What is a stage? What is a task? And what do you mean by the executors? And within that executors, I am having the slots. And those particular slots can be used for the parallel processing, all these kind of the conventions. And SQL or data frame, these kind of the constructs, you can see what exactly the things. And now we are not, we have not executed any code now, just we have taken the Spark and SC. For that only, it is recording many things. Whereas if I am writing some code in RDD or data frame or some sort of the optimizations, definitely it is going to help you. Suppose if you want to estimate some timing, maybe you are taking some multiple jobs, and if you want to identify how these particular jobs are running and is there any performance distinction, to perform all these kind of the aspects, you can make use of this thing. Okay, and the details. Okay, so as I said earlier, it is JVM based kind of thing. You can easily see, friends, here org.apache.spark dataset.kala. Okay, and some sort of Java based kind of the aspects also you can see, because this is at the end they designed in the JVM orientation. So definitely the job should be converted into those kind of the aspects. So these are all some of the things, whereas you can go and have a look on this stages and as well as the storage aspects. Okay. Now, just I'm giving you this kind of the convention in the chat window, guys, because Spark UI is not only identification of the resources, it greatly helps you to understand the architectural aspects also. Because in the architecture, we are having so many components. Okay, like starting from the job stage and as well as the task, and then we are having the executors and slots, cluster management. Because without understanding those kind of things, friends, just if you are learning the coding also, at some point of time, again, you should go back and verify those points also. So first we'll clear the architectural aspects so that you can have a look on what exactly the job flow and how it is performing the activities and all those kind of the conventions. Now, going back to our today's topic. So just if you are making use of the Spark context, just it is giving only the Spark context and remaining things are unchanged. Only the distinction, if I am asking, what is the difference between Spark session and Spark context? In Spark 1.x, only we are having the Spark support context. If I need to implement SQL based or Hive based, I need to explicitly add those things like Hive context and as well as the SQL context. But Spark designers place this particular Spark context, SQL context, and all these things in a Hive context in a single entry point, that is the Spark session. So your Spark session is available from 2.x, and those particular Spark session aspects are very much helpful. Without explicitly adding your Hive context or SQL context, even Spark context also will be scoped by the Spark session. Okay, majority of the times we are using the Spark session, but in some kind of the aspects, friends, especially in the RDD orientation, or maybe in terms of optimizations with respect to the memory or broadcast variables, definitely we need to use the Spark context also. I'll tell you the reasons, guys, because one important point, optimizations or memory orientation always very much close to your low level APIs, because in terms of operating system or networks also, the scheduling aspects, to understand the scheduling you should know the architecture, and even networks also, the subnet masking and as well as the physical bits. After identification of those things only, we are able to route those particular data and all. Similarly, in the understanding of this Spark-based terminology and Spark-based architecture also, you should have a look on all these components and underlying points, and especially if optimizations and memory orientation are coming into the picture, we should use the Spark context along with the RTD. Okay, however, I'll give you the reason for that so that you can also have a look on the point. Okay, right. I'll take a pause here, guys. If you're having any doubts, please put in the chat window. No, Ashlochan. We cannot modify the configuration because as we are dependent on the community edition, at least in this particular Databricks community edition, we are not able to perform the activities. But whereas if you are offered with proprietary edition, and if you are having the AWS or GCP or Azure official or proprietary kind of thing, definitely you can change the configuration. No doubt about that. Okay. So configuration, depending on the workload only. So like suppose how much amount of the data you are processing or what exactly your understanding of those things. Based on that thing only, you can perform the activities. Okay. Right. Now, uh, very good. So Vinay, Akhil has given the answer. Excellent. Elias. So Elias has given the answer like multiple computer work together to solve a common problem. Excellent, yeah. Very good. Surendra says distributed computing working on parallel servers together. Very near answer. Very near answer. Akhil says distributed computing the group of data items that can be stored in memory on worker nodes. Uh, Yeah, Akhil, again, so you're a bit tricky in answers. Let me clarify that, okay? But it's perfectly all right. Vedant says the technique of linking together multiple computer servers over a network into a cluster to share data and to coordinate processing power. Perfect, Vedant. As usual, as usual. As in other trainings, how you behave, you're behaving now also. It's not like, other way. Excellent. And Sahu says in distributed computing, components are present in different network computers, solve certain problems. Of course, almost you are there. Yeah, again, Sahu's okay. Shahrukh, data is distributed in cluster of computing. Yeah, in a simple answer, actually, that I cannot deny that is wrong. You have framed in such a way that is a advanced answer, I can say, rather than normal answer. Yeah. Let me put in this way, guys. In between, you can share your thoughts also. What exactly the distributed environment is built on top of that? Here itself will conclude. Assume that we are having some set of the machines, like that, plenty of machines. And as our friend said, all these machines are trying to uh, implement or solve a particular task. All these are trying to solve a particular task. Now you see, guys, here user one, user two, and user three. They are different users and trying to access the data, and they don't know how many machines are there, where they are located, and how they are processing. See, how many machines are there, where they are located, and what exactly they are doing. These things are very transparent to the user. This is known as single system image. What do you mean by this single system image, friends? Though I'm having plenty of tons of the machines, I can see that I'm only having a single system. Okay, so maybe if I want to access file one, I don't know where that file one is located and how I need to access without that. So there is one more layer called, okay, middleware layer, or else this layer is also known as distributed layer. Okay, now friends, distributed layer. So this distributed layer provides access to the appropriate users, and users are not aware of how many machines are there and how they are operating, what exactly their functionality, and how the data is processing all these kind of things. So the very first point related to the distributed environment is single system image. Second important consideration is all the machines, okay, whichever taking place, all the machines are working for a common task. So this is other important point. Third one is transparency. Transparency in the sense, guys, okay, location transparency, data transparency, okay, so migration transparency, and relocation transparency. Location, the user is not aware of where exactly that file is, which he is looking for, he or she. Data transparency, the exact information, what he is processing and data transmission, he is not aware of those kind of the convention. Migration, friends, one kind of the data is transmitted to another kind while processing the data, but he is not aware of that in the transformation or in the operations. He is not aware of the underlying point. Relocation. Sometimes, suppose due to the failure, because the main advantage of the distributed environment is reliability and availability. So if any problem is there for the current machine and whatever the file he is trying to access, if that file is not available, then immediately the distributed layer arranges one more machine. These things are not definitely known to the user friends. Okay, that is what we call the transparency. And last one, of course, one simple example I can give here, friends. Suppose I am using a single machine to perform reading of 1 TB of the data. Assume that it has taken. Always I used to give the same example for the sake of simple understanding. Now, rather, if I am making use of some 10 machines, okay, 1, 2, up to 10 machines to perform the same 1 TB reading. Obviously, your 45 minutes become 4.5 minutes. Okay, along with the single system image, along with the availability and reliability, along with the transparency, the time taken, okay, the time taken to perform some sort of the activity or to perform some sort of the task, the distributed environment greatly reduces the time factor. If I am not using the distributed environment and if I am only using a single machine, then it has taken some 45 minutes of the time. Whereas if I establish some different machines and if I want to use these kind of the machines to perform the common task of reading 1 TB of the data, our 45 minutes becomes very less. Okay. Now, one more a point I want to ask you here: parallelism versus distribution. How do you distinguish and how do you refer these two things, friends? Okay. So just have a look on this, and again I'm posting the same thing. So what do you refer by? And I got some more answers. Very good. Shanmuga Priya says. Distributed computing physically supplies servers, software applications, and storage. Is a more hardware-based answer, Shanmuga. Okay, I cannot deny that because yes, you are right. As I'm talking in front of software-based or some sort of the developer-based, you are talking about the hardware orientation, physically separated servers and all these things, maybe in terms of cloud-based aspects. One more point I want to ask you guys: parallel versus distributed environments. Okay, so environment and their unity. Okay, so bit tricky. Just to have a look on that, how do you come up with the parallelism and as well as the distributed aspect? And is there any common point? Like suppose I can say this example: algorithm and data, because algorithm is a program. The data is nothing but on top of the data your algorithm is going to act. Similarly, how can I say, software and as well as the I mean job and as well as the submission of the job to the cluster. Likewise, is there any way to combine parallel and distributed environments? Because definitely it is going to help us guys in the understanding of the big data architecture, especially in the Spark orientation. Because both Hadoop and Spark strongly support the parallelism and as well as the distribution. But we should know, as a developer, we should know that on which context I have to talk about the parallelism, on which context I need to talk about the distribution. That is the basic important point where you need to observe the orientation of parallelism and as well as the distribution. Now, let us go back to our discussion, friends. We stopped at understanding of the architecture actually. If you go back, just we have seen some sort of the points. And basically, one more important thing is as a task of the day, let me periodically post here so that you can prepare that thing. Like task one, catalyst optimizer, catalyst optimizer, and another thing is the tungsten, tungsten. Okay, so just you have a look, guys. However, in the next session, just I'll pick a person and he has to answer. But in the meantime, just you think through and have a look on this catalyst optimizer and tungsten because this is the latest venture of the Spark. How the catalyst optimizer empowers the running of the Spark and how our tungsten, because this is the most important thing, guys. Like, always the researchers and designers of the Spark, they strive for the betterment, and that's what they are ruling this data engineering. And of course, machine learning still scikit-learn only ruling the world, friends, to be frank. And at two, we need to see maybe in 6 months or in the span of 1 year, definitely, we are going to get MLib in a finest phase. Okay, but still, as a developers, we feel that like we are having some sort of flexibility with scikit-learn, especially in the machine learning zone I am talking about. Otherwise, in all the other kind of things, all the data engineering aspect or RDD or data frame or all these kind of the functionality is definitely very easy in case of our PySpark. Okay. Right, just to observe that point. And one more thing on top of these kind of the architectural aspects, just we are having the upper layers. Okay, just if you consider Spark SQL engine, completely they are distributed among Catalyst Optimizer and Tungsten. One thing I can give you here, hint kind of thing, friends. Like in every database or data warehousing kind of the environment, one of the important point is they provide some logical flow and as well as the physical flow of the data. Like on top of that logical flow, what they do is just they manage the convention of like whatever the functionality I'm having. Based on those kind of the functionalities, it is performing the activity. Like multiple logical flows would be there. Out of those particular logical flow, it observes one optimal logical flow. Similarly, here also, you can observe here why SQL engine has been attached here because we are not talking about Spark SQL, but still this is the architecture, friends. Actually, if you observe, this is the Spark architecture. This is not the Spark SQL, or this is not. I'm not talking about the RDD or data frame, but you need to realize that though we are talking about the architecture, your RDD is playing a vital role. Your Spark SQL is playing a vital role, so as to optimize the things and your data frame and all these kind of the APIs are playing a vital role. Okay, and there is a separate component called Spark SQL. Okay, where the entire programmatical aspects you can perform in terms of the Spark SQL orientation. And then, as usual, as I said, Spark is suitable for iterative, interactive. At the same time, it is providing some sort of streaming also. Okay, so those kind of the streaming aspects are also provided. with the Kafka or Spark streaming itself, you can perform the activity. Spark machine learning. This is what exactly, guys. If you refer, there are two genres actually. Let me introduce that thing. We are having the data engineering and machine learning aspects. Okay, coming to the data engineering is loading the data pre-processing, and again, if you are referencing these kind of the conventions, any handling of this data pre-processing again specifies missing value handling, feature engineering, and encoding. Okay, all these kind of the aspects can come under the category of the data pre-processing friends. So your data engineering, what it does is more or less to handle the data and data munging kind of aspects, data cleansing, and working with the data, loading the data, and pre-processing of the data, whether that particular data is up to the mark to be used by your model or algorithm, all these kind of the conventions. Whereas if I'm talking about the machine learning aspects, friends, it is something like building the model. Okay, model building and testing your model. Okay, and if your model is not performing well, we need to tune the performance tuning. Okay, all these kind of the conventions. So your machine learning, just it is providing some sort of the algorithms. Okay, friends, just we are having the classification algorithms. Okay, to name a few, just I can give you the support vector machine, naive Bayes, k nearest neighborhood, decision trees, random forest. Okay, all these kind of the conventions. Apart from that, we're having some sort of the regression also. Okay, regression based kind of the algorithms. Whereas we're having the simple linear regression. These are all the algorithms very helpful to us ML based folks. Simple linear, multiple linear regression, and thereafter we are having some sort of polynomial regression. Okay, likewise. And apart from that, guys, we're having the clustering also, clustering and association rule mining. Okay, so you might have heard about these terms, or else market basket analysis, or else principal component analysis, or dimensional reduction. Okay, and then we are having some gradient boosting. Okay, all these kind of the conventions. So your data engineering perspective is pre-processing and loading of the data, feature engineering, encoding, missing value imputation, all these things. Whereas your ML is some sort of the model building, testing the performance. And if the performance is not as per expected, we need to fine tune the performance. Again, with the classification, we're having the various algorithms like STM, naive Bayes, KNN, decision tree, random forest. Much more are there, but I have mentioned the most frequently used. In terms of the regression, also along with these three, we are having lasso, ridge, and elastic net. Those things are also there as a regularization and penalization. Simple linear, multiple linear, polynomial. Clustering, which is a unsupervised kind of aspect where grouping of similar kind of the item. Association rule mining, friends, here, suppose if I want to perform some sort of the activities, uh, for example, I'm working with Amazon log file, and maybe 20 to 25 members, 25 years members, which are all the products they are purchasing, maybe laptops or headphones, all these kind of things. And 25 to 35 members, they may be purchasing some sort of antivirus software or some sort of Hadoop the Definite Guide by Tom White or Spark Definite Guide by Miti Jaharia. Like that, they might be purchasing some sort of the books. Whereas the members from 35 to 45, they may be purchasing agile methodologies or PMP or Databricks. Okay, over the period, it is getting changed. So to estimate the sentiments and so as to handle these kind of the things, just we can make use of this market basket analysis. Okay, and one simple example, if you are going to a supermarket and if they are placing bread and milk together, 90% of the chances are there to purchase um, milk along with the this thing, actually butter and all these things. Okay, so the studies shows that if any product one and product two, if they purchase randomly, maybe if I'm not placing them in the nearest location, bread, butter, and jam, all these milk kind of thing. Though I'm placing them in four different locations, but majority of the members are going and picking up that. But whereas if you are keeping them aside, very nearby, then automatically the sales, not improved, but majority of the products are having that causal relationship. Like if they are purchasing product one, obviously they are going to purchase product two also. So these kind of understandings are possible with the association tool and as well as the market basket. And the PCA friends, actually that is the principal component analysis or dimensionality reduction, where so just we are making use of some sort of the algorithmic aspects. And while processing any data, our problem is not the number of records. How many number of records are there? No problem. But how many number of features we are having? Maybe thousands of features we are having, then we should pick up the features which are really helping us so as to perform the activities or so as to those features are really contributing. Though I'm having 1,000 features, but only few features are going to contribute. Okay, in the call, many members are there, but only 9 to 10 members are going to respond. Okay, likewise, in terms of 1,000 features are there, but still only few features we are going to get and perform the reality. So in that case, we need to pick up only those particular features which are really contributing to the algorithm, right? Okay, that is what you call the principal component analysis. And one more thing, always a machine learning engineer or data scientist strive for better performance. Okay, so though the data comes in all shapes, from the data engineers, just what you can do is you can ask the pre-processed data and fine-tune data, and then we are going to apply some sort of the algorithms. We are coming up with some sort of estimations and predictions. If those predictions are not still good, then we have to empower that model to reach to the level of betterment. So for that, we are having some sort of gradient boosting algorithms so as to boost up our prediction rate. So these are all the convention things actually. So before taking the break, let me see if I could get any outcomes. Very good solution. Says parallel environment, multiple tasks can run at the same time parallelly. Distributed environment data is available to all the devices. Excellent. Without any single word change, I can take that thing as it is, friends. Okay. Now, parallelism and distributed data is distributed throughout the network, hence multiple tasks or jobs can run on the same time efficiently. Excellent. Okay. And to simplify that thing, because that answer is perfect answer. And if you consider the thing, friends, like suppose I'm having the data, and the very first important thing is data and as well as the algorithm. So we are making algorithm move to data. This is a best convention thing because data may be 1 GB data or 1 TB data, but if algorithm hardly KBs only, no, just it is a code. So always it is preferable to transmit the algorithm to the data. That is the first point. Second important friends, always remember uh, your distributed environment related to the data or related to the memory, related to the space. Whereas your parallelism, okay, your parallel aspect related to the processing actually, related to the processing. Now, as if you consider there are process 1, process 2, and process 3, and my data is also distributed, okay, like there is a distributed storage, okay, your parallel aspects can run on top of this particular distributed machine. Simultaneously, it is taking some sort of the task and it is going to give the result. So the parallel and distributed environments, guys, together, they gives a kind of the performance benefit. And of course, our Hadoop and as well as the Spark are utilizing this parallel and distributed environment. And of course, one of the key performance aspect related to this Spark and Hadoop is parallel and distributed environment. Okay. So now we can stop here, guys, logically. Now, if any doubts are there, please let me know. Okay, I'll wait here. Meantime, let me start the timing, Google timer, so that exactly you can come back and we'll assemble here. And next steps, next we are going to talk about the excellent topic, guys, architecture, along with the RGD creation. Okay, because we were talking about the parallelism and as well as the distribution. So what we'll do is just we'll make use of that convention of identification of the RDD orientation. Okay. Now let us see whether our cluster is still in the up mode. Otherwise, we have to create one more cluster. So because that cluster is just simple thing where if you are not interacting with the cluster, it is going to end the appropriate support. So again, we need to create that. Okay. So I'll wait here, guys. Please let me know if any doubts in the discussed aspects. Maybe definitely today the Spark ecosystem architecture a little heavy, but from tomorrow onwards, definitely we are going to get a smoothness because programming definitely don't worry, guys. It's a simple thing and very handy with certain simple kind of narrations because it is a full-fledged APIs. No matter whether I'm working with the RTDs or data frames or some sort of optimizations in terms of UDF, everything becomes handy. Hope all the members are familiar with Python and little bit SQL. Okay, I'm assuming that if you are not familiar, please ping me, friends, so that I can see whether I need to conduct a primer course or because already Python course we have conducted so that I can ask Deepika to share the Python basics for big data or data engineering so that we can have a look on that. Okay, so accordingly we can flow. Right? So that's it. Let me share the timing. We'll have a break, guys. And once the break is over, just we'll come back and assemble here. Okay, thank you.